The province of Nova Scotia is in a high rainfall area and typically receives an average of more than 1,000 millimeters of precipitation annually. We receive much of our precipitation in the spring and fall, which can delay or make fieldwork difficult. How well water drains from fields is an important consideration when choosing a farm property. Field drainage is often a limiting factor as to what crops can be successfully grown, and it is estimated that 90% of soils in the province could benefit from tile drainage. There are a number of signs that your field may need surface or subsurface drainage. These signs include water ponding on the soil surface. Some fields may have depressions where water will pond. Land leveling can be done on small depressions to allow surface water to flow off a field. Larger depressions may need a surface inlet connection to a buried tile line to drain away surface water. Plants such as sedges and rushes are commonly found in wet fields. Improving the field's drainage is the best way to reduce their prevalence. Soil erosion and silt deposits caused by water traveling on the surface of a field can be a problem, especially on fields with long slopes and bare soils. Ditching and terracing across the slope can reduce the amount of water traveling down the field. White or gray-colored soil is a sign that the soil is waterlogged. Waterlogged soil may also be visible when you plow. The areas where the soil is gray in color are staying wet, resulting in restricted oxygen in the soil. Shallow rooting of plants is a sign that the soil is staying wet. Plant roots need oxygen. When soils are saturated, oxygen is restricted because the air pockets within the soil fill with water. Tile drainage is designed to remove the water in the air pockets. Surface and subsurface drainage can make some soils usable. Surface drainage or ditches can remove water before it flows over a field. This may be as simple as digging what is referred to as a cut-off ditch at the top of the field to catch and divert surface water away from a field. Cut-off ditches can also be dug across the long sloping fields. Another common type of ditch is the French drain. This type of ditch is filled with large field stones. Water has to flow around and between the stone, reducing the velocity of water in the ditch. French drains can also be driven over with equipment and eliminate the need for a culvert to be installed.
Similarly up here, this is a different, this is heavier soil. It's primarily silty deposit, silt deposit type soil. And it's underlaid by a gravel, hard gravel, though it's very difficult to dig. In fact, you can't dig it. You have to pick every bit of it. So it's like a glacial till underneath this. And that was one reason that there's a drainage problem. The water actually won't go through the gravel. It's that hard compact. It runs between the soil layer and the gravel layer and is forced to the surface. Well, the purpose of this trench is to allow water to leave this area. When a heavy rain occurs, water accumulates here quite a lot, and it stays for longer than I'd like. So I needed a way of draining it off quickly and allow the water to drain off the land above us here. The actual height of land is just 10 feet that way, and so this area doesn't drain that way. It actually drains that way, so I have to extend this ditch that way and fill it in. It's actually a French drain with a tube in the bottom, a big old 4-inch pipe. And it drains quite well. Does a good job.
Well, the drainage problem became fairly apparent the first year. I moved out here in the fall, and I had planted a green manure that cropped the spring before, taken it down in the fall, and then I planted garlic that fall. But I came in October and I planted in October, and I didn't know where the wet spots were in the field. And I happened to plant it in the wettest spot in the field with the porous drainage. So I knew immediately the next year that there was drainage problems, because we had anaerobic soil in certain sections. I could smell the soil. It wasn't draining properly. There was surface runoff. There was standing water. If we get a heavy rain, there'd be standing water in pools in the field, and it just wouldn't percolate down through the soil. So then, certain sections would run off, and I'd be losing we'd lose topsoil or any compost that I had added. So it became fairly apparent right away. I wasn't sure the first season whether it was just, whether it was an extremely wet season or whether it was going to continue to be a problem. But the second year we had, we had heavier rains, but we had, throughout the season I was seeing the same problems with water pooling on the surface, nothing percolating through runoff and crusts forming on top of the clay. So I could see that there was a problem with the drainage.
Many soils found in Nova Scotia are prone to compaction. A compacted subsoil layer can often be found between 30 and 60 centimeters depth. This dense subsoil will not allow water to percolate through, resulting in drainage problems. Subsurface drainage is also known as tile drainage and helps to remove excess water within the soil. Tile drains are 10 centimeters diameter flexible plastic pipes that have many small slits in them, allowing water to enter the pipe. Rows of pipe are typically spaced 12 meters apart and are connected to a main tile line that outlets to a low area. The tile drainage works best when installed across the slope of the field. When it rains, water percolates through the topsoil until it reaches a compacted layer of soil. Water then travels along the top of the compacted soil layer until it reaches a fractured area above the tile line. Tile lines are installed on a small grade so water that collects in the lines is carried off the field. The more slope on a field, the better the flow between the drains. Tile drainage does not work on fields that are flat. Tile drainage can be installed at an even spacing throughout a field. This is referred to as systematic drainage. Or tile lines can be installed to improve drainage in specific areas within a field. This is referred to as random tile drainage. Field drainage plans should be drafted by an agricultural engineer or an experienced tile drainage company based on field contour and slope. When only a few tile lines are being installed, the work can be done by a backhoe or excavator. For larger jobs, consider hiring a company that specializes in tile drainage. They will use a piece of equipment called a drainage plow to create a deep slice in the soil and lay the tile line in one pass. When installing tile drainage, the following points are critical. Number 1, start at your outlet to lay your main line. Number 2, lay tile lines across the slope. Number 3, bury your tile line at least 60 centimeters deep to prevent crushing by farm equipment. And number 4, ensure all tile lines have at least 0.1% grade. A grade of 0.5% is preferable. While tile drainage is costly to install, it should be considered a long-term investment. Tile lines and outlets may need occasional maintenance, but when high-quality pipe is used and lines are correctly installed, field drainage will improve for decades. Not all soils in the province have poor or imperfect drainage. Soils that are gravelly or sandy can have very rapid drainage. While they can be excellent soils for growing a wide variety of crops, these soils tend to be droughty and crops may require irrigation.
So it is quite an investment to have to put in tile drainage in your third year of production. I've been making incremental investments in the farm every year in terms of infrastructure, and was hoping not to have to make this one, but it just came to the point where I had to do it and had to put pretty much everything that I had from the last season back into the farm to put the tile drainage in this year. That is definitely it's challenging to have to come up with that much capital up front to get a job like that done.